All right, let's dive right in. Today, we're talking about the fundamental language of our entire digital world. We're going to break down how we actually teach computers to count, and it all comes down to translating art numbers into their native tongue, binary.
So let's start with a really core question. How do you teach a machine, your phone, your laptop, a giant supercomputer, how to count? It sounds so simple, but it's really a communication problem. See, they don't speak our language, so we've got to find a way to bridge that gap.
And the solution, really, is understanding that we're dealing with two completely different languages. You can think of it as a tale of two number systems, each with its own tiny little alphabet.
On one side, you have our system, which we call base 10. It's what we use every single day. It's built on 10 unique digits, 0 through 9. Pretty straightforward. But computers, they operate on something much, much simpler. Base 2, or binary. They only use 2 digits, 0 and 1. That's it. Think of it like a light switch. It's either off, a 0, or it's on, a 1. That's all a computer really understands at its core.
So for a computer to get a number, like, say, 128, we can't just hand it over. It wouldn't make any sense. We have to play the role of translator. We have to convert our base 10 number into its base 2 equivalent.
Now I know what you might be thinking. That sounds complicated. But here's the cool part. It's not. There's a surprisingly simple, kind of elegant method to do this translation, and it works perfectly every single time. It's all about simple division.
Okay, here's the whole game plan in 4 simple steps. First, you take your number and just divide it by 2. Then you write down the remainder, and it's always going to be either a 0 or a 1. Then you just take the answer you got, the quotient, and you do it all over again until that quotient becomes 0. Now here is the absolute most important part, the one everyone forgets. To get the final binary number, you read that list of remainders you wrote down from the bottom to the top.
All right, enough theory. Let's actually put this into practice and see how it works. We're going to start with an easy one and translate the number 128.
Okay, let's walk through it. We start with 128 divided by 2. That goes in perfectly, so we get 64 with the remainder of 0. Now we take that 64 and we do it again. 64 divided by 2 is 32, remainder 0. And we just keep going. 32 becomes 16, 16 becomes 8, and so on, until we finally divide 1 by 2, which gives us a quotient of 0 and a remainder of 1. Now just look at that neat little column of remainders we've made. So we've got our column of zeros and that one lonely one at the bottom. And now for that crucial step, the magic trick. To get the right answer, we have to read that list in reverse, from the bottom up.
So, reading from the bottom up, we get a 1 followed by 7 zeros. And just like that, the number 128 in our language becomes 1000000 in the computer's language. See? Not so bad, right?
Okay, I know. That one was pretty clean with all those zeros, so let's try a number that's a little messier, just to prove this method is the real deal and works for anything. Let's go ahead and tackle the number 139. We're going to apply the exact same steps. 139 divided by 2 is 69, with a remainder of 1. Then we take 69 divided by 2, that's 34, with a remainder of 1. And we just keep going down the line, and as you can see, this time we get a nice little mix of 1s and 0s in our remainder column.
And once we get all the way down to a quotient of 0, we take our list of remainders, read it from the bottom up, and there's our answer. The number 139 is 10001011 in binary. See? The method is flawless. It just works.
So, we figured out how to do the translation. It's a neat little math trick. But the real question is, why does this even matter? Well, this is where things get really, really big. Because this simple code of 1s and 0s is, and I'm not exaggerating, the foundation of our entire modern world.
This system is called binary code. It is the language that powers every single digital thing you own. Every single piece of information, a letter and an email, a single pixel in a photograph, a note in a song you're listening to, it all gets broken down and stored as a unique sequence of these 1s and 0s.
I mean, really think about it for a second. Every single time you send a text message or snap a photo or a stream of video, what's really happening is that billions of these binary translations are firing off in the background at speeds we can't even comprehend. It is the invisible engine that runs your digital life. So, the next time you're using your phone or computer, just remember this.
All of that incredible, mind-bending complexity, from streaming movies across the globe in an instant to the artificial intelligence that is literally reshaping our future, it is all built on top of that simple, repeatable process we just walked through. It all starts with dividing by 2.
A simple code of just 2 digits gave us the entire digital revolution. It completely reshaped our world. And it just makes you wonder, doesn't it? What will the next simple, elegant code build?